Good afternoon, class. As we've said yesterday, we're able to find a shortcut for similarity there, and we have three shortcuts: angle, angle, side, and side. So I'm going to write them here. So it's going to be angle, angle, side, angle, and side. So here we're going to use those three ideas to solve all these problems here. As here you can see, if I decide to extend this line LK and RQ and also extend this as well. So as you can see, if I draw this triangle and also draw this triangle, the angle that is common to them is angle P. And also, if I decide to use this angle here, K and Q are corresponding angles. L here and R here too are corresponding angles. So I only need two of these to show that angle. So here's they are similar by angle. Here, since I know, I have information about the three sides of each of the triangles, so I might use side. Okay, this is the best thing to do. This is the best way of doing it. And these two triangles are disjoint; they are far away from each other, so there's no angular relation. Okay, so here if I take big over big, that will be 40 over 16, which is 2.5. I'm also going to take the medium over medium, that's 35 over 14, which also gives me 2.5. And then lastly, small over small, that's 30 over 12, that gives me 2.5. As you can see, these three numbers are the same, 2.5, then I can say yes, since side is giving here, side here, so by SSS. And then here I have these two triangles, they are joined by this. As you can see, this first letter is the same as this first letter TT, so it means they're gonna cross. If they cross, they are vertical, so the verticals angles are always congruent. I have information about that this is angle. I have information about this side. So definitely if I want to use anything, I will use side. But how do I go with that? The next thing to do here is just to take corresponding side. So here if I take the two first letters TU, TQ, TU gives me 28, TQ gives me 16, so 28 over 16, 1.75. And also the first and the last, TV 35, let me change color, and TR 19, 35 over 19 gives me 1.842. As you can see, these two numbers are not the same, so here they are not similar. And on the right hand side, as you can see, this angle M belongs to this small triangle and the big triangle. Okay, and also have information about this side and this side. So if I want to prove it, only angle side can go here. Okay, for the meantime, because we don't have information if BC and LQ are parallel. Okay, so I'm gonna use the whole of this side LM. LM is the sum of 70 and 80, 72 and 8, so it's going to be 80. And then the small side of this triangle BM, which is 8, and 80 divided by 8 is 10. Other side, so the sum of Km is the sum of Kc and Cb, that's 45 plus 5, so that's gonna be 50. So I'm gonna have 50 over the small side here, which is 5. 50 divided by 5 is 10. As you can see, these two numbers are the same, so yes, they are similar by side, angle side. So we're able to do what we did yesterday as well. So here we're just gonna fill within the gap. So we're gonna fill within the gap, the empty space. So in this lesson, we are going to work on similar triangles proof. Okay. So we're gonna work on similar triangle proofs. Remember that there are 3 valid shortcuts. What are they? Angle, angle, side, angle, side, and side, side, side. So we are looking for congruent triangle. We are looking for congruent angles and proportional sides. Okay. So we have these two triangles here, uh, SVR and TVU. So it has been given that these two lines are parallel. These two lines SR parallel to TU. So I'm just gonna decide to extend TR and SU this way. So SR parallel to UT is given as it implies here. And then we see the measure of SVR is congruent to measure of TVU. As you can see, this angle here, this measure here is the same as this measure here because V is the midpoint. See the point of contact. V here is a midpoint in this triangle, is also a the mid letter. So the point of contact. Okay. So angle formed there, they are vertical angles. And you all know vertical angles are always congruent. So when also as you can also see, we can see the measure of angle R is quite congruent to measure of angle T here because R here interior. So these are alternate interior angles. Alternate interior angles are always congruent. Then we can say that triangle SVR is similar to triangle UVT. By what? Angle, because we had one angle here and one angle here. We don't need to prove the third angle, okay? So in this case now, triangle ABC is similar to DEF. So here, measure of D gonna be equals to measure of D here. Since D is the first letter, A is the first letter, so it's gonna be equals to measure of A. And then BE the last two, EF last two, AB first two, so first two gonna be DE. So you're gonna take DE here. That's how it works. And also BC, look at BC, last two, EF last two. Here BA, as you can see, ED over EF So ED correspond to what? The first two. The first two here gonna also be AB, but we are moving from E to D, so we have to move from B to A. That's why we have BA here. And here lastly, CA. Let me clean this. CA is from the first last to first. So last to first gonna be FD. Okay, CA or FD. Then we're gonna take ED, which shows this. So ED, E second to first. So second to first gonna be BA as well. So this is BA. And the measure of EDF. So measure of EDF gonna be equals to which? So E to D to F gonna be B to A to E, B to A to C. Okay, EDF, EDE from E to D to F, 2, 1, 3. So 2, 1, 3 gonna be B, A to C, B to A to C. So measure of angle BAC. So here, lastly, before I complete, DE first and second, AB first and second up here, and EF last second and last. So second and last here gonna be BC, and that concludes this chapter. So we're gonna have our review tomorrow and our test on Friday. Thank you.